Welcome to the Hypnos Sleep Channel. Tonight, Hypnos, the ancient Greek god of sleep, will guide us gently among legendary vessels of imagined starlight across long distances, quiet engines, and the deep dark between the stars. There are ships that were never built from steel or aluminum, only from imagination and light. And yet, for nearly 60 years, they have felt almost real. Tonight, we drift quietly through the decks of 10 of them. Vessels that carried entire crews across galaxies, across centuries, into the dark. Before we begin, let us understand just how large that dark truly is. A single light year is the distance light itself travels in one full year. Nearly 6 trillion miles crossed by something that never slows and never stops. The nearest star to our own sun, Proxima Centauri, sits 4.24 light-years away. At ordinary speed, in an ordinary ship, that crossing would take tens of thousands of years. And yet, the vessels in this story cross distances like that before a single sleeper finishes a dream. You do not need to remember their names or their numbers. You only need to let their long, slow journeys carry you down into your own. She was built in the 23rd century at the Fleet Yards above San Francisco. A Constitution-class heavy cruiser registry, NCC 1701, christened simply Enterprise, the third ship in Starfleet's history to carry that quiet, hopeful name. Her cruising speed on missions of exploration was warp factor 5. On the earliest scale, her engineers used warp 5 meant roughly 125 times the speed of light. At that gentle cruise, the 4.2 light-years to the nearest star would pass in only 12 slow days. In moments of true danger, she could be pushed further still, warp 8, warp 9 even, once, in a moment of crisis, past warp 14 though. Such speed strained her hull nearly to breaking. For decades, she served as flagship, carrying her crew on a 5-year mission to explore strange new worlds, to seek out new life and new civilizations. By the end of her service, she had grown old, reassigned quietly to train new cadets. And in the year 2285, she was given a final, deliberate rest. Let her be the first ship you drift with tonight, unhurried, outward bound at 125 times the speed of light towards something she could not yet name. Some years before her final rest, the first Enterprise was remade. Rebuilt, nearly hull to hull, her warp nacelles lengthened her systems, modernized for a new era of deep exploration. The refit gave her something new, a gentler, more efficient warp curve, allowing her to sustain warp 6 for long, easy stretches without straining her engines at all. A 6-month journey that once might have taken her old engines years could now be crossed in a single, unhurried season. It took long, patient years in dry dock before she was ready to fly again. And when she finally did, she looked, to her own crew, almost like a stranger, and yet unmistakably herself. This is the quiet secret of every ship that lasts long enough to matter. She is rebuilt again and again and somehow remains the same soft idea underneath. Decades later, a new Enterprise was born. A Galaxy-class starship, vast and slow and gentle, nearly 642 meters long, carrying not only her crew, but their families too. She was commissioned in the year 2363 under the command of Captain Jean-Luc Picard. Her maximum safe speed was warp 9.65. On the newer, gentler scale, her era used a scale where the numbers climbed slowly, then suddenly toward warp 10. That top speed carried her at several thousand times the speed of light. At full stretch, she could cross a distance of 100 light-years in only a matter of weeks. Her saucer section could separate from the rest of the ship, entirely drifting free, while the drive section carried the danger away from those who needed to be kept safe. For 8 long years, she served as flagship until, at last at a place called Viridian 3, her long service ended, and she was recovered, slowly rebuilt once more into a quiet, resting museum. A ship remembered instead of flown. One more Enterprise followed, a Sovereign-class starship, sleeker, newer considered, in her time the very edge of what Starfleet knew how to build. Her cruising and maximum speeds matched her sister ships of the era, but her engines ran cleaner, more efficient, able to sustain those same staggering thousands of times light speed velocities for far longer without rest. She launched on stardate 49827.5 from the same quiet fleet yards above San Francisco where the very first Enterprise had once been born. Captain Picard commanded her, too, carrying forward almost the entire crew of the ship before her, as if a name and a purpose and a velocity could simply be passed forward hand to hand, generation to generation, like a lantern carried through the dark. Now, drift further into the 24th century to a smaller, faster ship, the USS Voyager, an Intrepid-class vessel, only 344 meters long, half the size of the great Enterprise that came before her. Launched in 2371 under Captain Catherine Janeway, her maximum sustainable speed warp 9.975. Nearly the fastest a Starfleet vessel of her time could safely travel thousands upon thousands of times the speed of light. And yet, even at that astonishing pace on her very first mission, she was pulled suddenly, impossibly 70,000 light years from home, into a distant, unmapped region called the Delta Quadrant. At her best cruising speed alone, that crossing would have taken 70 long years. For 7 of those years, she found her way back one quiet star system at a time, borrowing, once, a fragment of Borg technology, a transwarp coil that let her leap 20,000 light years in a single, breathless moment, shaving 15 long years from her voyage home. She was never the largest ship or the strongest, only the most patient. Let that patience settle over you now, too, the way Voyager carried herself home one slow, careful light year at a time. Not every ship built for exploration was built for peace. The USS Defiant, small, heavily armed, built quietly after the Federation's costly encounter with the Borg, to be something Starfleet had rarely needed before. A warship. Barely 170 meters long, she carried a maximum speed of warp 9.5 upgraded, later in her service to keep pace with the greater ships around her. Small and swift and able to vanish entirely. She carried a cloaking device borrowed carefully from the Romulans, allowing her to slip past enemy sensors unseen at any speed she chose. Commander Benjamin Sisko helped design her aboard the station called Deep Space Nine. She served faithfully through difficult years until, at the Second Battle of Chintoka in 2375, her long service came to its end. Even a ship built for conflict may be remembered gently for how faithfully and how quickly she carried those aboard her. Turn now toward a very different design. Sharp-winged predatory, the Klingon bird of prey, small, agile warships flown for centuries between the 22nd and 24th centuries. Built for speed over distance rather than distance over comfort, these ships were never meant for years-long voyages. They were built for raids, for sudden, decisive strikes, crossing a handful of light years in a single night, then vanishing behind a cloak before a response could ever reach them. Armed with disruptor cannons and photon torpedoes, they trade the deep, patient ranges of an Enterprise for the sudden, sharp velocity of something that means never to be caught. And yet, even a ship built for war moves, in the end, the same way every ship does. Quietly through the vast, uncaring dark, carrying someone who simply wants to come home. Larger and slower to reveal themselves, the Romulan D. Deridex-class warbirds, drift now into view. Massive, over 600 meters across, double-hulled, shaped like a great closed wing folded around a hidden heart. What they lose in agility, they gain in endurance, capable of sustaining high warp across distances that would strain a smaller ship for months at a stretch without ever needing to slow. Like the bird of prey, they could vanish behind a cloak, appearing to any watching sensor as nothing but empty, silent space. For centuries, the Romulan people preferred to be seen only when they chose to be. There is something almost restful in that kind of patience. A ship content to simply wait in the dark unseen until the moment it is ready to be known. Now the dark grows a little colder. A vast geometric shape drifts into view, enormous, a single unbroken cube, nearly 3 kilometers along each edge. The Borg cube, home to a hive mind, thousands of individual voices joined quietly into one single, unbroken thought. It does not travel by ordinary warp alone. The Borg move, when they choose to, through transwarp conduits, vast, hidden corridors folded through space itself nearly 50 times faster than the highest warp speed any Starfleet ship can safely sustain. At that velocity, a distance that might take Voyager 70 years to cross could be closed by the Borg in a matter of months. There is no need to fear that speed here tonight, only to notice how vast a distance can shrink once patience gives way to something colder and far more certain. Even damage does not truly harm the cube, it simply regenerates slowly the way a wound closes itself in sleep. Let your own thoughts fall into rhythm too, and at the very center of this long, slow journey, not a ship at all. A station. Deep Space Nine, orbiting patiently near a distant planet called Bajor, never moving faster than the slow, steady turn of its own orbit. Once built for a difficult, painful purpose, later repurposed as a place of meeting, of commerce, of uneasy peace between people who had once been enemies. Its long, docking arms reached outward into the dark like open, waiting hands. Nearby, a stable wormhole, a natural fold in space itself, connected it, in a single instant, to a region 70,000 light-years away, the very same distant quadrant that once swallowed Voyager whole. A single step through the wormhole's shimmering threshold crossed, in a heartbeat, a distance that would otherwise take a lifetime to sail. Ships came and ships went, Enterprise and Voyager and Defiant and Bird of Prey and Warbird, every vessel in this long night's journey passed, at some point, through its quiet, waiting arms. A single, still point in a galaxy that rarely holds still. Before these vessels power down, let us linger with the idea that carries all of them. Warp itself, the fictional speed that makes every long journey feel almost possible. Before there was a Starship Enterprise, before there were warp cores and dilithium crystals and chief engineers shouting about the laws of physics, there was a man in a small town in Montana. His name was Zephram Cochrane. In the Star Trek universe, Cochrane built humanity's first warp-capable vessel, the Phoenix, in the aftermath of World War III. On April 5, 2063, he launched from Bozeman, Montana, using a converted intercontinental ballistic missile. When the Phoenix broke the light barrier, the subspace signature was detected by a passing Vulcan survey ship. First contact, the moment humanity joined the galactic community. The warp drive Cochrane built worked by generating a subspace field around the ship. This field warped the fabric of spacetime, contracting space in front of the vessel and expanding it behind. The ship itself never exceeded the speed of light within its local reference frame. It was spacetime that moved. This is the same principle Miguel Alcubierre would formalize in his 1994 paper, 3 decades after Star Trek first imagined it. Cochrane's original warp scale was simple. Warp factor 1 was the speed of light, and the velocity increased as the cube of the warp factor. Warp 2 was 8 times light speed. Warp 3 was 27 times. Warp 4 was 64 times. Warp 5, 125 times the speed of light. This cubic scale was the law of the original series era. Captain Kirk's Enterprise, a Constitution-class heavy cruiser, could sustain Warp 6, 216 times light speed. In an emergency, she could push to Warp 8, 512 times light speed. At those speeds, the journey from Earth to Alpha Centauri, 4.37 light-years away, would take approximately 8 days at Warp 6. But the stars are far apart. The Federation spans 8,000 light-years. Even at Warp 8, crossing from one end to the other would take more than 15 years. The galaxy is vast, and the original series warp scale, for all its simplicity, could not keep up with the storytelling demands of a universe that kept getting bigger. When Star Trek: The Next Generation premiered in 1987, the universe had expanded. The Enterprise D was a Galaxy-class starship, larger, faster, more powerful than anything Kirk had commanded. The old cubic warp scale was no longer sufficient. The writers needed ships that could cross the galaxy in weeks, not years. Gene Roddenberry and the technical consultants devised a new warp scale. Warp factor 1 remained the speed of light, but from Warp 9 onward, the scale became asymptotic, approaching infinity as it neared Warp 10. Warp 10 was not a speed. Warp 10 was everywhere at once. It was infinite velocity. It was, in the words of the Star Trek: The Next Generation Technical Manual, the theoretical maximum. The new scale was defined by the equation: velocity equals the warp factor raised to the power of 10^3 multiplied by the speed of light. For warp factors below 9, this produced speeds roughly in line with the old cubic scale. But above Warp 9, the numbers exploded. Warp 9.0, 1,516 times light speed. Warp 9.6, 1,909 times. Warp 9.9, 3,053 times. Warp 9.975, approximately 5,000 times. Warp 9.99, 7,912 times. Every decimal point mattered. The difference between Warp 9.9 and Warp 9.99 was the difference between crossing the Federation in a year and crossing it in a month. This asymptotic scale created drama. The Enterprise D had a normal cruising speed of Warp 6, 392 times light speed. Its maximum sustainable speed was Warp 9.2, 1,649 times light speed. In an emergency, it could push to Warp 9.6 for 12 hours. Beyond that, the ship began to tear itself apart. The scale also created limits. If Warp 10 was infinite, it was unreachable except through extraordinary means. This was explored in the Voyager episode Threshold, where Lieutenant Tom Paris breaks the Warp 10 barrier, and the results are not what anyone expected. He experiences being everywhere at once, every point in the universe simultaneously, and the experience transforms him into something no longer entirely human. The episode was controversial among fans, but it established a fundamental principle. Warp 10 is not a destination. It is a boundary condition. It is the edge of what physical law permits. Every starship class had its own warp capability, its own relationship with the speed scale. These numbers were not merely technical trivia. They defined the character of each vessel, the reach of each crew, the scope of the stories that could be told. The NX-01 Enterprise, Earth's first Warp 5 starship, launched in 2151 under Captain Jonathan Archer. Warp 5, 125 times light speed, was the threshold that made interstellar exploration practical. At that speed, the journey to the nearby Klingon Empire, approximately 100 light-years from Earth, took less than a year. The NX class could sprint to warp 5.2, approximately 140 times light speed, but sustained speed was lower. This was the ship that built the alliances that would become the Federation. Kirk's Constitution-class Enterprise operated on the old cubic scale. Warp 6 cruising, Warp 8 emergency. At Warp 6, the 5-year mission to explore strange new worlds could reach any star within approximately 100 light-years of Earth and return. This was the scope of the original series, a frontier measured in hundreds of light-years, not thousands. The galaxy was still huge, but it felt approachable. The Excelsior class, introduced in Star Trek III, The Search for Spock, was designed to be the great experiment. Transwarp drive, a propulsion system that would render the old warp scale obsolete. Transwarp failed. The Excelsior was refitted with conventional warp drive and became the workhorse of the fleet for nearly a century. Its top speed was Warp 9, 729 times light speed under the old cubic scale, or approximately 1,000 times light speed under the new asymptotic scale, depending on which reference you consult. The Ambassador class, Enterprise C, bridged the gap between the Excelsior era and the Galaxy class era. Warp 9.2 cruising, Warp 9.6 emergency. This was the ship that sacrificed itself at Narendra III, defending a Klingon outpost from Romulan attack. An act of honor that would reshape Federation-Klingon relations for a generation. The Galaxy-class Enterprise D was, in its era, the pinnacle of Federation engineering. Warp 9.6 for 12 hours. At that speed, the ship could travel approximately 2,000 light-years in a year. The Enterprise D could reach the edge of the Federation and return within a standard tour of duty. But even a Galaxy-class ship could not explore the entire galaxy. The Milky Way is 100,000 light-years across. At maximum warp, crossing from one side to the other would take nearly 50 years. The Intrepid class, Voyager, changed the equation. Its variable geometry warp nacelles, the pivoting pylons that raised before engaging warp drive, were not merely aesthetic. They were a response to a Federation study that showed standard warp configurations were damaging the fabric of subspace. The Intrepid class could maintain warp 9.975, more than 3,000 times light speed, for sustained periods without causing subspace degradation. This was the ship that was hurled 70,000 light-years across the galaxy to the Delta Quadrant. At maximum sustainable warp, the journey home would have taken 75 years. Voyager's entire premise was the tension between that number and every shortcut, every wormhole, every alien technology that might reduce it. The Sovereign-class Enterprise E, introduced in Star Trek. First contact, push the envelope further. Warp 9.7 cruising, Warp 9.99 emergency. At those speeds, the Federation's reach extended to thousands of light-years within a standard mission duration. This was the ship that faced the Borg, and won. The Prometheus class, an experimental vessel introduced in Voyager, was capable of Warp 9.9, more than 3,000 times light speed, and could split into 3 separate warp-capable sections. Multi-vector assault mode. 3 ships attacking from 3 directions, each traveling faster than anything the Federation had fielded a generation earlier. The Prometheus represented the apex of Starfleet's tactical warp technology. And then there were the ships beyond Starfleet. The Borg cubes, traveling at transwarp speeds through conduits, artificial corridors of subspace that connected distant regions of the galaxy. Transwarp rendered the standard warp scale meaningless. A Borg cube could travel from the Delta Quadrant to Earth in minutes, not decades. The Voth, an ancient Saurian species from the Delta Quadrant, possessed transwarp drives that made even Borg technology look primitive, crossing thousands of light-years in seconds. At the far end of the scale, species 8472 from fluidic space used quantum singularities to travel between dimensions, a form of propulsion that was not warp drive at all, but something fundamentally different, the manipulation of the boundary between realities. The warp scale, for all its complexity, was always a local convention. It described what the Federation could do, but the galaxy was full of civilizations that had outgrown it. The in-universe physics of warp drive is explored across hundreds of episodes and films, and while it is fictional physics, it is internally consistent, a remarkable achievement for a television franchise spanning 6 decades. The core component of any warp propulsion system is the warp core. This is a matter-antimatter reactor. Deuterium, a hydrogen isotope, is injected into the reaction chamber. Antideuterium, antimatter, stored in magnetic containment bottles, is injected simultaneously. The two annihilate on contact, releasing enormous energy. This energy is regulated by dilithium crystals, a fictional mineral that is porous to antimatter when exposed to high-frequency electromagnetic fields. The dilithium crystal acts as a throttle, controlling the rate of annihilation and therefore the power output. The energy from the warp core is channeled to the warp nacelles, the elongated pods mounted on pylons away from the ship's hull. Inside each nacelle are a series of warp coils, typically made of verterium cortinide. When energized by plasma from the warp core, these coils generate a subspace displacement field, the warp bubble. The bubble is asymmetric. It compresses space in front of the ship and expands it behind. The ship rides inside a region of flat space-time, never locally exceeding c, while the bubble itself moves at effective superluminal speeds. This is precisely the concept Miguel Alcubierre would formalize in 1994. A warp bubble that contracts space-time ahead and expands it behind, with the ship riding a wave of warped geometry. Star Trek got there first, in 1966, as fiction. The mathematics caught up 28 years later. The subspace field serves a second function beyond propulsion. It reduces the effective mass of the ship, a phenomenon the technical manuals call subspace driver coil mass reduction. In Newtonian terms, the ship becomes lighter within the field, requiring less energy to accelerate. This helps address the energy problem. Even with matter-antimatter annihilation, the power required to accelerate a 4 million-ton starship to relativistic speeds would be prohibitive without mass reduction. Warp drive in the Star Trek universe has limitations and dangers beyond mere speed. Sustained high warp travel, above warp 5, was discovered in the TNG era to cause cumulative damage to the fabric of subspace. A region of space, repeatedly traversed at high warp, would develop subspace rifts, tears in the underlying structure that could disrupt warp travel and, in extreme cases, threaten inhabited worlds. This was the so-called Warp 5 speed limit imposed by the Federation Council, later relaxed as new nacelle designs, such as Voyager's variable geometry pylons, mitigated the damage. Warp drive also creates a detectable signature. A ship at warp emits subspace radiation, warp signature, that can be detected at considerable range. Stealth at warp is nearly impossible. The approach of a high warp vessel is visible for light hours in every direction. This is why cloaking devices were so coveted, not because they hid a stationary ship, but because they could hide a ship traveling at warp, something that no other technology could do. The Romulan and Klingon cloaks that so bedeviled Starfleet were, at their core, a solution to the warp signature problem. Let us now make a quiet journey through the warp scale itself, from factor 1 to the edge of factor 10, and see what each threshold means, not as a number, but as an experience. Before we leave the solar system behind, it helps to anchor the scale in familiar distances. Light from the Moon takes about 1.3 seconds to reach Earth. Light from Mars, depending on where both planets are in their orbits, takes roughly 3 to 22 minutes. Jupiter is usually tens of light minutes away. Saturn is a little over an hour of light time away. Neptune is about 4 light hours from us. At Warp 1, those are still the travel times: seconds to the Moon, minutes to Mars, hours to the outer planets. But at Warp 5 on the next generation scale, those same distances nearly vanish. Earth to Mars becomes a matter of about 1 to 6 seconds. Earth to Jupiter becomes roughly 10 to 15 seconds. Earth to Saturn becomes about 20 to 25 seconds. Earth to Neptune becomes a little over 1 minute. At Warp 9, even Neptune is only about 10 seconds away. This is why Star Trek rarely treats planets inside one solar system as truly distant. The real ocean is not between Earth and Mars. It is between stars. The nearest star system, Alpha Centauri, is 4.37 light-years away. Sirius is 8.6 light-years away. Epsilon Eridani is about 10.5 light-years away. Tau Ceti is nearly 12 light-years away. These names are close neighbors by cosmic standards, but at chemical rocket speeds, they are effectively unreachable. Warp drive changes the emotional meaning of the map. It turns light years from walls into weather. Warp factor 1, the speed of light. 300,000 kilometers per second. At this speed, it would take a little over 4 years to reach Alpha Centauri. The nearest star is close enough to feel, but not close enough to touch, not in any human lifetime. Warp 1 is the gate. It is the moment the Phoenix broke through and everything changed. Warp factor 2, 8 times light speed on the original cubic scale, and just over 10 times light speed on the later next generation scale. Alpha Centauri in roughly 5 to 6.5 months, depending on which scale the story is using. The nearest dozen stars become reachable within a single mission. This was the speed of the earliest Earth warp vessels, the ships that charted the first trade routes to Vulcan and Andoria. Warp factor 3, 39 times light speed on the TNG scale. Alpha Centauri in 40 days. The distance from Earth to Vulcan, approximately 16 light-years in 5 months. This was the dawn of true interstellar civilization. Warp factor 4, 102 times light speed. Alpha Centauri in 15 days. At this speed, a ship could visit a dozen star systems within a year. The NX-01 Enterprise, Earth's first deep space explorer, operated in this regime. Warp factor 5, 214 times light speed. Alpha Centauri in 1 week. Earth to Vulcan in less than a month. This was the speed threshold that transformed the Federation from a collection of neighboring worlds into a true interstellar power. Warp factor 6, 392 times light speed. Alpha Centauri in 4 days, the standard cruising speed of the Galaxy-class Enterprise D. At Warp 6, the ship could cover approximately 400 light-years in a standard year. This was the speed of routine operations, of patrols and scientific surveys and diplomatic missions. Warp factor 7, 656 times light speed. Alpha Centauri in 2.5 days. At this speed, the ship begins to feel the strain. Warp 7 is the boundary between routine travel and the high warp regime where subspace damage becomes a concern. Warp factor 8, 1,024 times light speed. Alpha Centauri in 36 hours. At this speed, the Federation's fastest ships, Intrepid class, Sovereign class, begin their sprint regimes. Warp 8 was emergency speed for the Galaxy class, sustainable only for hours. Warp factor 9, 1,516 times light speed. Alpha Centauri in just over 1 day. 1 light year every 5 3/4 hours. The ship is now moving through the galaxy at a pace that makes the local neighborhood, stars within 50 light years, feel like suburbs. Warp factor 9.2, 1,649 times light speed, the maximum sustainable speed for a Galaxy-class starship. At this velocity, the Enterprise D could theoretically cross the width of the Federation in approximately 5 years. Warp factor 9.6, 1,909 times light speed, 12 hours maximum for a Galaxy class. The hull temperature approaches 1500 Kelvin. The structural integrity field is at 110% of rated capacity. The chief engineer is staring at a display that is mostly red. Warp factor 9.9, 3,053 times light speed. Extreme high warp travel, where every decimal place matters. At this speed, a ship moving in a clean, straight line could cross 70,000 light-years in about 23 years, if nothing went wrong, which everything always did. Warp factor 9.975, approximately 5,000 times light speed in many technical references. The Intrepid-class maximum sustainable sprint is often associated with this part of the scale. In pure arithmetic, 70,000 light-years at 5,000 C would be about 14 years. Voyager's famous 75-year journey therefore tells us something important about story world travel. Maximum listed speed is not the same as average practical speed. Routes are indirect. Supplies run low. Engines need rest. Space is full of hazards, politics, detours, hostile territory, and tempting shortcuts that may or may not be traps. Every hour at high warp is an hour closer to home, but the galaxy still resists being crossed. Warp factor 9.99, 7,912 times light speed. Sovereign class emergency speed. The Enterprise E pursuing the Borg, defending Earth, pushing further into the curve. At this speed, 1 light year passes every 66 minutes. The ship is held together by structural integrity fields and the sheer will of its crew. Warp factor 9.999, approximately 100,000 times light speed. Theoretical limit of Federation warp technology. No Starfleet vessel has ever achieved this speed in normal space. The energy required approaches infinity. The subspace field begins to interact with the quantum vacuum in ways that are not fully understood. Warp factor 10. Infinite velocity. Everywhere at once. The point where the warp factor equation becomes undefined. In the Star Trek universe, Warp 10 has been achieved exactly once in recorded Federation history, by Tom Paris in the shuttlecraft Cochrane, using a new form of dilithium that allowed the warp field to cross the asymptotic barrier. The result was transformation. Paris became a creature of pure energy, existing at every point in space simultaneously before being returned to human form. The Federation classified transwarp, the regime beyond warp 9.99, as too dangerous for further flight testing. The scale does not truly end at 10. It approaches 10 as an asymptote, a line that is forever getting closer but never touched. And in that approach, in that infinite sequence of nines after the decimal point, is the entire romance of warp drive. The speed is not a number, it is a direction. It is the refusal to accept that any distance is final. When Star Trek was being filmed on the Desilu lot in 1966, no physicist would have said warp drive was possible. Faster than light travel was science fiction, pure and simple. Einstein had spoken. The speed of light was absolute. But Star Trek's version of warp drive, the warp bubble, the contraction of space ahead, the expansion behind, turned out to be not merely science fiction. In 1994, Miguel Alcubierre proved that this configuration was a valid solution to Einstein's field equations of general relativity. The mathematics worked. The universe permits a region of space-time to move faster than light, provided the region itself is carried by the geometry of space-time rather than accelerating through it. Alcubierre's warp bubble contracts space in front and expands it behind. The ship sits in a flat region at the center. Inside the bubble, all the laws of physics hold exactly as they do on Earth. There is no time dilation, no relativistic mass increase, no violation of causality at the local level. The crew experiences nothing unusual. Outside the bubble, from the perspective of distant observers, the ship has moved faster than light, but it did so by surfing on space-time, not by breaking it. This distinction matters because special relativity does not merely say that engines are not powerful enough to outrun light. It says that as an ordinary object with mass accelerates closer and closer to light speed, its energy requirement climbs without limit. A conventional rocket cannot simply push harder until it passes C. It would need infinite energy. Warp drive tries to avoid that trap by moving the geometry around the ship instead of pushing the ship through local space faster than light. The energy requirement was the problem. Alcubierre's original calculation suggested that a warp bubble large enough to transport a starship would require negative energy equivalent to more mass than the entire observable universe. This was not an engineering problem. This was a physics problem. Negative energy, matter with negative mass, which would fall upward in a gravitational field and push instead of pull, has never been observed in macroscopic quantities. But there is a glimmer. The Casimir effect demonstrates that quantum fields can produce regions of effectively negative energy density, very small regions, for very brief durations, but real. And beginning in 1999, Chris Vandenbroek showed that by modifying the geometry of the warp bubble, making the interior microscopically thin while keeping the exterior shape, the negative energy requirement could be reduced by dozens of orders of magnitude. By 2011, Harold Sonny White at NASA had reduced the estimate for a usable warp bubble from the mass of the universe to approximately 700 kilograms of negative energy. Still unachievable. Still exotic, but no longer cosmic. And in 2021, Eric Lentz showed something remarkable. Subluminal warp drives, bubbles that move slower than light, but still faster than any rocket, can exist with positive energy only. No exotic matter required. The Lentz drive and the related Bobrick-Martyr classification of warp drive spacetimes demonstrated that warp technology is not forbidden by known physics. It is merely enormously difficult. There are deeper problems too. A faster-than-light warp bubble may create horizons, regions where information cannot easily travel from the front of the bubble back to the ship. It may sweep up dust, gas, and radiation as it moves, turning ordinary interstellar particles into a dangerous blue-shifted storm. It may raise causality questions because in relativity, faster-than-light travel in one frame can resemble time travel in another. And even if a bubble could be made, it would have to start, stop, steer, and avoid arriving with catastrophic energy concentrated at its bow. The mathematics opens a door. It does not yet give us a spacecraft. The connection to Star Trek is not accidental. Alcubierre has said in interviews that he was directly inspired by the show. The warp bubble he described in classical general relativity is, in its essential geometry, the same configuration that Zefram Cochrane built in a missile silo in Montana in 2063. The mathematics caught up to the imagination, and the imagination had a head start of 28 years. The warp scale from 1 to 10 is a map of that belief. Warp 1, the gate. Warp 5, the threshold of true interstellar civilization. Warp 9, the sprint into the unknown. Warp 9.999, the edge of what is possible, the asymptote, the line forever approached and never crossed. And Warp 10, everywhere at once, not a speed, but a condition, not a destination, but a transformation. Between these vessels, it helps to understand the dream they all share. In their fictional universe, warp is not ordinary motion. The ship is not imagined as a bullet crossing space by brute force. It rests inside a shaped region of spacetime, while the field around it shortens the distance ahead and lengthens the distance behind. That difference matters because it gives the dream a calm, internal logic. A starship can travel faster than light, in effect, while the people inside still walk across the deck, drink coffee, repair conduits, and look out at the passing stars as if the ship were almost still. The earliest warp scale was simple. Warp factor 1 meant light speed. Warp 2 meant 8 times light speed. Warp 3 meant 27 times light speed. Warp 5, the first great threshold of human exploration, meant 125 times the speed of light. At that speed, the nearest star becomes a voyage of days rather than a silence of generations. The map changes in the mind. A light year stops being only an impossible distance and becomes something like weather, something a patient vessel can move through. Later stories used a newer scale. The numbers rose gently at first, then more and more steeply as they approached Warp 10. Warp 10 was not treated as 10 times anything. It was a boundary, an asymptote, a place where the idea of speed begins to lose its ordinary meaning. This is why the highest decimal places matter so much in starship lore. Warp 9 is fast, but Warp 9.9 is not just a little faster. Warp 9.975 is another kind of promise entirely. Each 9 after the decimal feels like one more hand reaching toward an unreachable horizon. The NX-01 Enterprise belongs near the beginning of that promise. She was small compared with the vessels that followed, and her top speed was modest by later standards, but she carried the first deep space confidence of Earth. A ship like that does not need to be the fastest thing in history. It only has to be fast enough to make the unknown practical. The Excelsior class carried a different kind of dream. She was built around the idea of transwarp, a propulsion breakthrough that was meant to make the old scale obsolete. In the story, that first great experiment did not work as promised, but the ship survived the disappointment. She became a workhorse instead of a miracle, and sometimes that is the more lasting achievement. The Ambassador class sits quietly between eras. It is not remembered as loudly as the Constitution class, or as visually as the Galaxy class, but it carries the feeling of a bridge. Old design language flowing into new design language. Older ideals being stretched until they can carry a larger, more complicated century. By the time the Galaxy class appears, the ship itself has become almost a moving city. Families live aboard. Children look out of windows at nebulae. The bridge is not only a command center, but a room designed for conversation, diplomacy, and long thought. The scale of the vessel changes the emotional texture of exploration. The Sovereign class narrows that feeling again. She is sleeker, more guarded, built for an era in which exploration still matters, but danger has come closer to home. Her speed feels less like leisure and more like readiness. She is the same hopeful name carried through a more anxious age. Voyager's speed is tied to longing. Warp 9.975 sounds triumphant until the ship is thrown 70,000 light-years from Earth. Then, speed becomes arithmetic, and arithmetic becomes grief. Every shortcut matters. Every engine repair matters. Every friendly star system is a small mercy on an impossibly long road. The Defiant's speed is different again. She is compact, overpowered, and urgent. Her engines are not built to carry families across years of peaceful survey work. They are built to arrive quickly, strike hard, and survive the kind of danger Starfleet once hoped it would never need to design for. The Klingon bird of prey treats velocity almost like a hunting instinct. It appears, crosses the dark, and disappears again. Its cloak changes the meaning of motion because a visible ship announces itself by traveling, while a hidden ship turns distance itself into strategy. The Romulan warbird is slower to reveal its intentions. Its great double hull gives the impression of something folded around a secret. The ship can wait in silence for a long time, and that patience is part of its power. Not every fast vessel feels hurried. Some move quickly only after choosing exactly when to be seen. The Borg cube makes speed feel inhuman. It does not need grace, silhouette, or tradition. It is a geometry with engines. Through transwarp conduits, distances that exhaust other ships become corridors. The cube does not seem to travel so much as arrive, and the calmness of that arrival is part of what makes it unsettling. Deep Space Nine changes the question altogether. It does not have to be fast. It sits beside a wormhole, and the wormhole does what engines cannot. A station becomes a crossroads because space itself has opened a passage beside it. The fastest vessel in the story may be the one that never moves. The fictional engineering underneath these journeys has its own quiet architecture. Matter and antimatter meet in the warp core. Dilithium regulates the reaction. Plasma moves toward the nacelles. Warp coils shape the field. The details are invented, but they are invented with enough care that the ship begins to feel internally real. In that imagined engine room, energy is not just power, it is trust. The crew trusts the containment field. The ship trusts the nacelles. The nacelles trust the mathematics of subspace. Every long journey depends on thousands of invisible agreements holding steady in the dark. There is also a real-world echo beneath the fiction. In 1994, physicist Miguel Alcubierre described a mathematical warp bubble in general relativity, contracting space ahead and expanding it behind. It did not make starships practical, and it did not give humanity an engine, but it showed that imagination had touched a shape mathematics could recognize. The problem was energy. The original idea required exotic negative energy in quantities far beyond anything nature has shown us how to gather. Later researchers changed the geometry, reduced the estimates, and explored slower warp-like bubbles that might not require exotic matter. The door did not open, but it stopped looking quite as much like a painted wall. Even so, real warp travel remains far beyond us. A bubble would have to form, steer, stop, and avoid turning interstellar dust into a storm of blue-shifted radiation. It would have to preserve causality, protect its passengers, and obey constraints we may not yet understand. The dream is not engineering, not yet. But dreams can still be useful before they become machines. A fictional vessel gives the mind somewhere to stand while thinking about scale. It lets a listener imagine 4 light-years, 10 light-years, 70,000 light-years without being crushed by the numbers. It turns distance into a corridor with lights along the floor. That may be why these vessels remain so easy to remember. Each one gives a different shape to the same impossible wish: to go farther, to return safely, to carry a name forward, to cross the dark without becoming empty inside it. The first Enterprise carries the wish as a beginning. The refit carries it as renewal. The Enterprise D carries it as home. The Enterprise E carries it as resolve. Voyager carries it as patience. Defiant carries it as protection. The Bird of Prey carries it as nerve. The Warbird carries it as secrecy. The Cube carries it as inevitability. Deep Space Nine carries it as stillness. And above all of them is the deep dark itself. Not hostile exactly, not kind either, simply immense. A place where light needs years to cross from one star to another, and where a story can make the crossing feel, for a while, almost tender. So when a starship goes to warp, the image is not only spectacle. The streaking stars are a symbol for every distance the mind has ever wanted to soften, every grief of separation, every unanswered signal, every map with more empty space than names. The vessel becomes a small promise moving through the unknown. A promise that someone can leave and return, that the dark can be crossed, that the far shore, even if it is fictional, can still teach the heart how to imagine arrival. There is another quiet way to measure these ships, not by speed, but by what kind of time they make possible. A slow ship makes every journey a farewell. A fast ship makes return imaginable. A very fast ship changes the emotional shape of home itself, because home is no longer a place abandoned forever, but a point on a map that can still answer. The original Enterprise makes time feel exploratory. 5 years sounds long, but not endless. It is long enough for friendships to deepen, for maps to fill in, for a crew to become a small civilization of its own. The ship is fast enough to keep wonder moving, but slow enough for every arrival to matter. The Galaxy class makes time feel domestic. A child aboard that ship might measure childhood in star systems, birthdays in different sectors, school lessons beside windows that open onto nebula. Its speed is not only strategic, it is social. It allows ordinary life to exist inside extraordinary distance. Voyager makes time feel moral. 70,000 light-years is not simply a number. It is a test of what a crew will preserve when no one nearby can enforce its values. Every decision on the long road home asks whether distance has changed who they are, or only revealed it more clearly. Defiant makes time feel compressed. There is rarely the luxury of a long survey or a slow diplomatic approach. The ship exists for moments when hesitation becomes dangerous. Its small frame and heavy engines turn time into reaction, into response, into the hard work of protecting fragile places. The Bird of Prey and the Warbird make time feel hidden. Their cloaks create waiting rooms in space, silent intervals where no one knows a vessel is present. A cloaked ship does not merely hide its shape. It hides the moment of its arrival, and in doing so, turns timing into a weapon. The Borg cube almost removes time from the equation. It travels through corridors other ships cannot use, repairs itself without drama, and moves with the terrible patience of a machine that does not feel late. Against such a vessel, speed becomes less like adventure and more like inevitability. Deep Space Nine answers all of them by remaining still. It shows that motion is not the only way to cross a distance. Sometimes the universe folds nearby. Sometimes the road comes to the harbor. Sometimes the most important vessel is not the one with the strongest engines, but the one that waits beside the opening. So the story of these ships is also a story about different kinds of patience. The patience to explore, the patience to repair, the patience to return, the patience to wait unseen, the patience to stand still while half the galaxy passes through your doors. And this is why the deep dark feels less empty after a while. It is filled with possible routes, with imagined engine signatures, with fictional hulls carrying real human hopes. The starfield may be silent, but the mind keeps placing vessels inside it, one after another, each with its own soft light in the windows. There is nowhere further to travel tonight. So softly, one by one, let each vessel's engines power down, the Enterprise folding gently backward through each of her own familiar names and each of her own familiar speeds. Voyager turning, unhurried toward home, 70,000 light-years now quietly behind her. Defiant, Bird of Prey, Warbird cube, each one quietly dimming like a light turned down rather than switched off. and Deep Space Nine, holding its place patient at the center of it all long after every ship is gone. They were never built from steel or aluminum, only from imagination and light. And yet, for nearly 60 years, they have carried quietly across an ocean of screens and stories something that felt almost real. 6 trillion miles in a single light year. 70,000 of them crossed by one small, patient ship. Tonight, they carried you too a little further into the dark. Let them rest there, now in the quiet among the stars, and rest alongside them.